So as Gert already hinted on, I'm going to talk about a collaboration project that Work Package 2 did in the more or less the last year. And the talk is mainly based on a paper which we wrote together, which is has also the same title. So it's on quantifying uncertainty in projections of future European climate, a multi-model and multi-method approach. And yeah, obviously this is not only my work. So Carol did a lot of work in this, and basically everybody involved in Work Package 2. So just to acknowledge that. So Gert was already nice enough to kind of repeat the Work Package 2 objectives, so I can more or less skip this slide. Just to mention that basically this work was mainly focusing on the kind of first three bullet points on this slide. So we tried to test and develop new and existing observational emergent constraints, and then use them to produce uncertainty distributions of future change. And it also goes a little bit into the whole point of natural variability and determining the contribution of natural variability in the total uncertainty. So I don't think I need a lot of motivation here. Basically, I would only mention really quickly the second part of this slide. So there is a lot of different approaches that exist to create such kind of probabilistic estimates of future change. We collected 6 methods from the different partners in Work Package 2. And in the paper and also in this presentation a little bit, I'm going to look into the properties of the methods and their underlying assumptions. So looking a little bit into the questions, do they produce the same output? If they don't produce the same output, what are reasons for that? We look into the different sources of uncertainty the different methods cover. This is an important point. And yeah, finally, we kind of compare those methods, as I already mentioned, and see if they agree in their projections of, and we focus on mid-century temperature and precipitation change. And in addition, again, Gert already mentioned that as well, we look into some methods which only focus on internal variability. And those are methods which use only one model, but then a kind of large ensemble of these models, while all of the other methods, so the 6 methods I mentioned above, are using a multi-model ensemble. So this is also something Gert has already shown. I just wanted to mention this again here. So a large part of this kind of undertaking was actually to come up with a common setting which we can use to quantitatively compare the different results. So we were trying to get something which is applicable for every method, so that we can then run the method on this given setting and then really have results that are comparable. So this is what we came up with basically. So we're looking at summer temperature and precipitation change between a reference period and a mid-century period. We're looking at 8 different regions in Europe. And the idea here is that these regions also represent 3 different domain sizes. So we have all of Europe, and then we have the 3 SREX regions, and then we have 4 single grid points. So it's important here to mention that we not necessarily think that looking at a single grid point in a global climate model is very meaningful, but one idea here is also to compare the methods and to look if where is kind of the point where they maybe break and not produce meaningful results anymore. So yeah, as was already mentioned, we're focusing on CMIP5 models because at the point when we started, there was just not enough CMIP6 models available. So for now, all of what I'm showing is based on CMIP5, and we're using the RCP 8.5 if possible. So it's not applicable for all methods. And already here I'm hinting at one important point. So one important difference between the results is based on using different model subsets, and I will talk about this a bit later. So these are the methods. This is a table from our paper. I hope you can more or less read this okay. I'm going to go through it on a kind of top levels. I'm not going into any details of the methods. I guess the experts in each of these methods are also in this call. Maybe if you have any questions, you can just chat with them privately or pose it at the end of the talk. So one category of methods is weighting schemes. So these are the ETH method and then the EUCP method. So they basically weight each model in an ensemble based on some measure for performance and independence. The second category would here be the methods from Edinburgh, which is detection and attribution based and kind of constrains future projections based on a comparison with changes in the past. Then we have a group of Bayesian methods that kind of update a prior probability distribution based on additional information coming from the observations in the historical period. And finally, again, we have the single model methods, which are conceptually a little bit different as they focus on the internal variability. So the one main part of the paper is a comparison of the results of the methods. So we use them to constrain our future projections and create kind of PDFs. And the plots I'm going to show are a little bit complex. So I start with the empty one here to kind of go step by step. So for each of the methods, we're going to show an unconstrained distribution. This is the kind of lighter in the background, lighter box in the background, and the constrained distribution. That's the darker one in the darker one in front. And I'm always showing the 90% range, 50% range, and the median. So what we also do is we show an estimate of kind of a long-term internal variability based on observations to see if any of the changes emerge from internal variability. So this would be for one method, showing the unconstrained, and then on top of it, the constrained. So in this case, the method doesn't constrain its prior. And one important thing we tried, and which is also, I think, a task which Work Package 2 is working on, is coming up with some kind of summary of all of these methods, and I will talk about this in my conclusions. And what we try here is to do like what I call percentile summary. So on the very right-hand side of the plot, you can see like one line for the 10th percentile, for the 50th percentile, and for the 90th percentile. And this will be done for each method. And this is just to make it easier to understand how far the different estimates from the methods are apart from each other. So the lines, just to be clear, are the constrained estimates from each of the methods that are going to appear in just a second. So this is for one method. And then we have all of the other methods which are multi-model methods here. And on the right-hand side, you now see kind of the range that the 3 percentiles are covering. So one more thing, you notice that there is different colors for the bars. In the moment, we have two different colors. So yellow indicates that the methods are based on CMIP5. And the EUCP method, that's the reddish one, is actually based on CMIP5 plus perturbed parameter ensemble. So that is to indicate that there is a different model pool in the background. And the other thing you will also notice is that actually already the unconstrained distributions can be quite different. And this again is based on the fact that the methods use different model pools. And then in addition to these kind of multi-model methods, we have also single model methods, which are only based, as I said, on one large ensemble. And here we have 3, which only at the moment use this kind of unconstrained distribution because they're conceptually a little bit different. And then we have the call method from the University of Oxford, which kind of does a recalibrating of the unconstrained to make it, to bring it together with what is observed as well in the past. Right. So I hope this is more or less clear. Yeah. Sorry, was there a question?
8 minutes.
I made 8 minutes? Oh God. Okay. So this is one of the result slides. This is showing temperature. Again, we have at the left top the whole European domain and then the 3 subdomains, the SVEX regions. And just focus on the very high level messages. So the different methods lead to a spread reduction of about 20 to 30%. There's quite high agreement in Central Europe and the Mediterranean, not so much in Northern Europe, where the methods partly disagree, particularly if you look if the unconstrained is kind of shifted upwards or downwards. And in general, also we find that the agreement is higher in the median and less so in the upper and lower tails. So that's kind of an important high-level message for maybe risk-averse users. So this is, maybe I skipped this a little bit. This is kind of looking at the same model subset to control for the differences from different model subsets in CMIP. If you're interested, I can send you the paper for this. For precipitation in Europe, so this again the same for regions, we find that the differences are considerably larger. And one important thing that leads to these differences is also the influence of internal variability. So there's just the influence of internal variability is significantly more important here. And this is also the point where I should mention that not all of the methods treat internal variability in the same way. So the HIST-C and the ASK method both do not include internal variability anymore, where the other three multi-model methods still include internal variability. So this is one of the reasons why there is differences in the different estimates. This is a bit more summarized comprehensively on this slide, where we ask the questions, why do the methods differ? Again, different model pools, the methods might have different underlying assumptions. And there is quite some differences in the uncertainties accounted for. Again, internal variability is one of them. Then we have a parameter uncertainty, and also the carbon cycle uncertainty is, for example, considered in the EUCP method, but not in the other methods. And then, of course, the informing fields. So how do the methods get their information for constraining? Is it based on time series information, or is it based on field information, or maybe a combination of both? That brings me to the outlook in, to kind of stay in time. One important thing we want to do is come up with some kind of method synthesis. At the moment, we are only able to do this, what I call here, method envelope. So that was the spread on the right-hand side. That is very transparent and simple, but it's no real progress compared to model democracy, where we just use the unconstrained. So there's different approaches to this. One would be to combine the methods before applying them. That would make it possible to draw from all of the different lines of evidence from the different methods, but it's probably very hard to implement because it would more or less require the development of a completely new method. So what we're going with at the moment is to combine the results of the methods using some kind of skill measure. And these are just some slides that Chris sent me. So what we're trying to do at the moment is to do an out-of-sample testing and basically applying the methods again to CMIP5, but instead of observations, we use CMIP6 as pseudo observations. That allows us to inform the methods, kind of calculate the distribution, and then evaluate the distribution in the future period against the same CMIP6 models. So this is kind of our plan for the out-of-sample testing. And I think in the interest of time, I'm just leaving it there. I'm happy to take any questions.
Okay, thank you very much, Lucas. Okay, is there a quick question from anyone? Paul, have we got anyone on the...
Jason's raised his hand.
Okay.
Jason?
Very quick question from me. In the combining the methods, is there also scope for perhaps including a level of risk aversion from the user? So that could go beyond just the envelope method, but it might give something additional to particularly risk-averse users or users that at the other end of the scale are not so risk-averse?
I think this is definitely something we can consider, yes. So as I said, if you're interested in the median change, it doesn't even matter so much which method you're looking at. This is very different for the higher percentiles. So this is one point. I think the other point is, sorry, let me just, as you can see, for example, for precipitation, there's very, very different estimates. So one could just say I'm going with the worst case scenario, which I don't know, for the Mediterranean would be the ASK method here, and kind of use again the envelope and say just use the edge of the envelope, but maybe we can also do something better. So I think this is definitely an interesting question that should be asked, and I think there's also interest, as far as I know from the groups, to look into this a bit more.